Welcome everyone to today's video, and it is Octane time again because people are begging me for some release already half a year ago and now. And the problem is that I can't yet spin ISO images. Not only do I not have a CD-ROM, but that's not the biggest problem. The other problem is that the SGI optical discs are a little bit special in getting them to boot. Not sure if they need a volume header or a SGI file system or both. As I remember, there was only a proof of concept ISO ever or so. And while I will most likely get T2 to automatically build bootable ISOs on the Octane later this winter, one generous subscriber even joined Patreon just for this. The problem is twofold. Not only do I not want to leak here private information like root passwords that I may or may not use also on other vintage machines, I also have here two installations, this new and this old one. If we archive here the whole disk image, I would not want these two different systems here, effectively doubling the size. That is of course suboptimal. So we also need to shuffle this around and see that everything still boots. This is a real danger here, that if I move things around here, that things still boot and everything. So let's, in this new system, set the test password. Can only hope that boots. What is here, the FS tab? It is not here, root and swap. So copy this FS tab also. And we also need to delete some more stuff, like my home directory. Apparently don't have it here right now. Tape test, because I have here at least music files that we would not want to leak for copyright infringement reasons. Certainly can't. This we can already delete. Should not be anything that I would miss, I guess. Of course we will later zero this all out, otherwise it will still be included in the disk image as deleted inodes. But not that we forget it here. So, and we should at least test boot this once. This engage scripts there are for change routing into this. I guess we can do away with this, and also obviously all the root stuff here. These are some subversion passwords and bash history. And aside from this, we need to move, by the way, so this system here is GCC unrecognized option version. So this is GCC 404. And this is 494. Are we even rolling? Not that I entertain myself here. So what we need to do next is move all this to the top level. And the problem is, as soon as we move this top level files, we will not have working executables as they are dynamically linked, and they will not find their shared objects anymore, their shared libraries. And for this I usually have emp utils, and they are empty because maybe diet-libc didn't work. Do we have the embedded utils here? Here we have them, and they bus error. Thought so already. Maybe I should also in the future load here a larger console font that the audience at home can better read it, I guess. We should probably also be able to mount and bind mount things from in there. Let's see, can we just for a test move this to the top level? Yeah, that we can. It's often not so easy to know from the different systems how they behave with bind, mount and change root and binaries, memory mapped and such, what works and what doesn't. So move everything here. So, and as I expected, now we can't run new binaries except if we type a full parse here, like ld linux loader. Actually, even that is slightly inconvenient. That is what I usually have the statically linked embedded Linux things for. Without the statically linked fallback, it's slightly more difficult, actually. I also need to get diet-libc working. Maybe I have done already. So lib32 LD, you can run this statically like this, and library parse new, maybe it's often bin ls. Yeah, whatever is this. Ah, this works. But yeah, I realize this is super small. Sorry for that. So with LD library path, we can still run these executables and move here. So what we need to do next is, we have this N32, so now we want to move everything from the N32 new, from this top level. By the way, maybe we first check what we have left in this top level. Our proxies temp are still mounted, that is true, so these mount points could not be moved. Maybe we then simply move all of those manually here. What will it do when it exists? Okay, let's try. And what is our result? Our result is we have some working binaries. So we have now, we also need to keep the argcf and this xorg and impact we have in the system. We've even still everything on the... Yeah, sorry, that is slightly drawback of small fonts with a relatively high resolution. We probably also want to keep the kernels here, because I'm not sure what kernels, do we even have something there? And we have something, but we probably better... Here, so then let's delete here this and move the old kernel and such over here. And the only things we have not moved is devproc this. Do we have dev? We have proc. We have this, and we don't have dev. Okay, but anyway, it doesn't matter. Move old dev here. And rename new to old. So I think this could potentially be all shuffling around. This are booting as 4.12 with the other audio fix. Yeah, now we have some dev init controls. We were not booting from that. Let's see how that goes. Control Alt Delete to trigger the init system running in the other partition, or to trigger the init system running from this other change root from the old system. Yeah, fingers crossed. These other things just sent me an image and I sit here 1 hour just moving things around, wiping information, testing that it boots, risking that it doesn't boot, and so on. So much to the, can you just send me some image? Fingers still crossed. Time for a coffee. Arcload still loads from the volume header. Kernel still loads from the file system. Init still coming up. There's being something with some read-only system, but this could potentially be okay. Sometimes there are some spurious things that I have not yet cleaned up. And okay, this is the init with this bug or regression that it's cleaning the screen that I didn't like. Made a video about this earlier. And test. Yeah, we have a login. Lucky us. By the way, I also wanted to check which CPU. It's a dual 250. This should be the system where X comes up. Yeah, X comes up. I've not yet figured out the mouse cursor color map. I think I know where it is, but somehow it doesn't work. There's also some test binaries that we may want to clean up in user x lib something xorg. Where are the xorg drivers? Modules, drivers, passes never can be too long. Here's some out. I was doing some register filling. Nobody needs this. This backup is probably also some not working. And what else do we have? So aside from this, I guess we can wipe everything in this old. And the next thing is, of course, now a risk. I could have made a new backup and everything, but I have already too much data here everywhere. Just set up the new 12 terabyte server in the beginning of the year and such here in the office. And we also have commercial project data for OCR and such, consuming a lot of space, and I can't keep backups of each and every gigabyte here and there. Problem is also that things bitrot and become vintage, and then you have copies of everything. So next thing we want to do, core dump, thank you very much. Okay, then F disk, I need to figure out this diet-libc stuff. So actually this disk is not so big, so when I just compress everything together you need a at least 4 gigabyte disk, but that is what you have to live with now. Otherwise we could potentially resize this, but I will not bother doing this now. To resize this, to allow restoring this to a smaller disk, you now need at least 4 gigabyte. That's what it is now. Just plug in an equal so many sectors or bigger disk and you should be fine. To wipe even more data, so password is test. What is in the bash history? Yeah, okay, that isn't everything harmless now. And to wipe even more, so everything else should be gone, I hope. And can also clean the core dump while at it. And now to avoid, when we now back up here the whole SDH, we will back up all the random noise, all the old files and everything, all the deleted inodes will live the content. So to wipe as much as we can, vdd input file 0 to output file 0, zeros, and block size 4K, and do we have IO stat? We don't have IO stat. So do we have subversion? We have subversion that you can check out T2 and continue building it. Emerging things and such. And by the way, I also installed Blackbox already the other day for your immediate startup pleasure, as well as RxVT Unicode and some Vera bitstream fonts that you have at least somewhat nice X. And let's kill here the user 1, the background process. Or is it not new enough? Core dumped. Thank you very much. So much to that. Normally this is print out status, but then maybe without status, whatever. As I said in an earlier video, this is the most stable installation I ever had. But one thing, the statically linked diet-libc stuff, and also occasional things like this, like killing user 1. So I would have expected that such travel things work, but apparently not. But that are all the small details here and there that everyone always thinks you compile it and it just works. No, you compile it and you have regressions, and small details like this don't work. And I did not even know this with this DD. I guess I remember something was fishy with ditlipsy, but I did this port myself. I thought it was working a decade ago. Not sure what I've done last December. But yeah, I already further investigated the mouse cursor. I know now where the color map registers are. Writing to them does not have yet effect. I think you need to do some other bus mode address selection stuff there for this to work. But we will be getting there. We will continue this hacking series in the winter somewhere. Maybe one of you has time and motivation to fiddle around in there and find something out. And yeah, otherwise, chances also that if we recompile things will just magically repair themselves. And also, I intentionally use an older GCC. You have seen we use here now 494, and I think I've used a much newer GCC. I think in an earlier video in the beginning of this year I showed using GCC 7 or 8 or something, but that was at least 25% slower, and I intentionally rebuilt this with a much older GCC that is still new enough for a lot of fancy features to work, for improved compile times. Otherwise, if you want a new compiler, just use T2 and cross-compile a new build route, a new second stage. And yeah, with the latest GCC, the last time I did this, it worked. It just was at least 25% slower, and that is a little bit hurting on this already not as fast systems anymore. After 2 decades, obviously, depending on what kind of Octane you have, single or dual, 195 MHz up to 600 or so. But I guess few people have 600. And by the way, if you have a dual 400 or 600 Octane 2, it would be awesome if you would donate it to me. We can even change, because I for sure can use a faster Octane. You can also use Patreon to donate. So this exited. Let's see, we have only 20k space left. So then let's delete the zeros, and the hard drive should now be completely overwritten with zeros. And yeah, you can not only watch the YouTube advertisement, you can also join Patreon to fund my open source work, and also use Amazon affiliate links under the videos. In some countries, the Amazon affiliate multiplexer CGI link there on below most of my videos works for the American, German, France, Spanish and Italian. If you need something from Amazon, you can always use these links to, at no extra cost for you, donate a little bit to us. And yeah, now let's cut this together. By the way, this uncompressed, these are 2.5 GB with all the headers and static libraries and things like that. And maybe even log files. By the way, we could... Did I copy this with the T2 log files? Yeah, sure enough I did. Let's do this again. Saves a bit of space. And using this ways you can give a little bit back. And to finish this, we will use netcat. Yeah, don't have netcat here. Yeah, we could connect some external SCSI hard drive or such, but I will probably... Emerging the T2 source is not that big. By the way, we can probably do this in the background. So I usually have the T2 source and user source T2. So svn checkout. This way, the T2 source code is certainly more useful than the log files, and we also need Wi-Fi for that. There's right now no Wi-Fi config, but you can just use DH client. And here, having the T2 source ready for you is certainly more useful, especially with the correct configuration to build for the correct MIPS and MIP64 and 32, and is more useful than the log files in the archive. Yeah, makes the download a little bit bigger, but for 2.5 GB that shouldn't matter too much, and certainly is way more convenient for you, and then I avoid endless of questions how to check out T2 and configure it and emerge something. So yeah, let's do that. Subversion checkout later. I also copied to the configuration via building T2 saves the configuration in etc SDE config. Previously that was raw config. This is just some legacy naming stuff. Nowadays I would probably just name it etc config or something, but that's what it is now. I'm not a fan of changing things just to change things. Let's check here the config. That should probably, I hope that compiler and everything works well enough for this config to work and come up. This will probably take quite a while on dual 250 megahertz. I also took memory out, right? Let's see. So password is test right now. We have, or did I take it out from the other one? 3 does not support H. Wonderful. Oh, looks I have a gigabyte RAM in there. Yeah, wonderful. Rounding, a gigabyte is 0. Awesome usability, yeah, but nearly a gigabyte apparently. Then I took it out from the other one, right? But this compilation is not memory limited anyway. So this is purely CPU limited. There's few compilations there. And are we even running this in parallel? I think, yeah, I changed this recently. This is at least running SMP2 now. Then we simply quickly emerge netcat and we will simply netcat this over Ethernet to the ThinkPad and then finally have an image for others to download and a backup for myself. Some minutes and a phone call later. So this is a config. So there was this picture not once clearer, but this could also be... Anyway, so we have here MIP64. Wish this dialog stuff would look better. Actually, we could probably change the config. The problem is changing the config is relatively slow because this is programmed in shell scripts and such. So now all the shell script machinery is doing all their SED and stuff like this, unfortunately. And then I only need to check that we default to this N32 user lint. And then we are also not a cross build. Yeah, we have here default to 32-bit N32 because this is slightly faster for more compact pointers and such. And yeah, cross build we disable that and no binaries with debug symbols. So one more. Yeah, you really don't want to run the config so often, especially not on a slower vintage machine like this. Now it should work that we emerge like netcat, and this may find here some deps. Some, by the way, are stray deps like the package because it's called something to probe something or so. And we want to cancel this, and probably we can also update Perl from since the beginning of the year when I built this in February or something. There are Perl and glibc may have been intentionally older, and Patch and Perl and even Bison. But we don't want any of this, so we run here with steps none. We just want netcat and then it's compiling this from source here. And you see this is quite stable. As I mentioned in my earlier first time SG Octane stable on Linux video a decade ago, this was barely booting, crashing within a minute or two. I don't think it survived much longer than the first test programs or test shell or something. I have no idea how this for Skylark, who did all the original reverse engineering, but maybe the Debian people had some special blessed binaries with some special custom patches or something like that. Anyway, now we are here. Nowadays we can also cross-compile this from a AM Ryzen or Threadripper. And yeah, as you see, this is the reason this was compiling some wrappers that the T2 system is using, and these are relatively small files, and you see each of these files takes some seconds to compile. Now this is running the build shell scripts and extracting the tarball and running all the other configure, make install stuff or whatever netcat is using. And this is exactly the reason why I went here with a build with an older GCC, because 25% slower than this is really no fun. So let's prepare here netcat on the ThinkPad. This is, by the way, why I prefer displays like this. By the way, maybe we restart this, and so netcat, also no netcat here. And this is why I prefer displays like this with at least 3 or so display inputs. Maybe this even has 4, but even my 15-year-old display has 3, 2 times VGA and DVI. This one has 2 times DVI, mini DisplayPort and DisplayPort or something, maybe even HDMI or something. Much more awesome for professional work than Apple displays with 1 input or something. So netcat, one is listening, so netcat listen. Need to read the min page, what that was, port and whatever. And yeah, what is the default port? Oh dear, netcat listen pipe to IP30. Obviously the mobile AMD Ryzen builds this here in a snap, in a second or less. And here we are still running in var rdm log configure. Yeah, we're compiling there. So probably soon we will be ready here. By the way, is the date and time correct? That surprisingly is quite correct, not 100%ly, but no NTP date, okay, whatever. So netcat, let's see, netcat, what is that IP? Okay, so this looks like it should work. So netcat -L -P, 10,000 import, pipe to set standard for compression, and so listen here. And netcat here, and we want to netcat SDA, and we should see here we get 7 megabyte a second. I think Octane only has 100 megabits, so that is relatively close at the theoretical maximum. And we can also check if we are compression limited, and we are probably not. Set standard only takes here 22% CPU load, but we should also have seen this here already, where we are not getting that much CPU load actually. 2, 8, 9, 4, yeah, you name it. So we are compressing there. That should take 4 gigabyte divided by 7 megabyte a second, 7.3 even, and this divided by 60, maybe 10 minutes. Good also for the fun. Check our load here on the Octane. So on the Octane we are indeed 99% CPU limited on netcat, surprisingly. Maybe we should have used some zero copy kind of operation. We are running, no actually we are, wait a second, why is this? This is not idle? Right, because this is combined CPU. So we are running, so actually have most of this 96% load time in kernel, mostly on one of the CPUs, only 25% in user space, 75% in the kernel, more or less. And yeah, so reading, programming the SCSI controller and the NIC for sending the packages out. Actually interesting that everything is on one CPU, but maybe the Linux kernel is intelligent enough to keep it on one CPU, whatever. So yeah, there we have it. Netcat is finally running to allow the audience at home to play along soon on their Octanes. I hope you enjoyed this video and learned something, and don't forget to share, like and subscribe. Use the affiliate links, subscribe on Patreon, and I also hope to see you soon for the next videos to come. So looks like we are done. Unfortunately this netcat doesn't stop there nicely. I thought it should. No. Let's think, how do we maybe close? Should it with Control C or not to lose any byte at the end there. The size of this is 429 something. Maybe check a little bit for integrity. Okay, this stopped now. Let's quickly uncompress this. There may be no parallel multi-threaded decompression or so. Whatever. Decompressing this with 60 megabyte. But somehow not CPU limited. No load average. Why do we have such a high load average? Whatever. Okay, but now we can verify the size here. IP30. So this R42931 42931 81952 81952. Yeah, so this is accurate. Then we can copy this to the server, and so then let's rename this more accurately to some T2 MIP64 IP30, maybe some subversion revision later, revision need to check what exactly that was, and image set standard also, and checksum this.